Cool. Okay, so we'll do a general overview of DevOps first. And so that's going to be, I believe, like 30 minutes. Oh, let me just check how long I have. Oh, okay. So I have an hour to go through and tell you all about basics of DevOps. All right. Sorry, give me 1 second. All right. Okay. So as I mentioned, I don't work in DevOps specifically. And so if I don't know a term, we will literally Google it together and figure it out. But generally, what is operations? Operations from a business perspective is keeping the lights on and keeping the doors open to a company. And so that's a little bit different from DevOps, which is kind of a software term or like a tech term. So operations generally is running the business and keeping things going operationally. And so what are SREs? SREs are site reliability engineers. So that is a defined role that a person, like it's like a job title. Like it's a role someone has inside the company, and their job is to keep the website running, for example, or the app online, and the app like talking to the server, front end connected to back end, stuff like that. DevOps is, yeah.
So for SOEs, doesn't it should be available 24 hours a day?
Yeah, so that is called being on call. And so typically how that would work is it's part of your employment contract to have certain hours that you're available or a certain number of hours in like a week that you are available to be on call. And usually you would want 24-hour coverage for everything all the time, ideally with like a backup person in case you're sleeping or you get hit by a bus or something. And so that is on the DevOps lead, whoever you have, because that's typically done in a bigger company. Like in a smaller company, you don't have like a dedicated, defined on-call schedule, usually. What was that?
Yeah, that was the question.
Okay, cool. Cool. And so in DevOps, it's really a lot of different things, like deploying new updates, or like deploying the app in the first place, deploying the site in the first place. That's part of DevOps. And then managing it, like making sure it doesn't go down, maintaining it, and then if it goes down, fixing it. So that's all included in the term DevOps. And so it's like everything related to being online and everything related to everything working. And so that's the general encompassing term for DevOps. Cool. Infrastructure automation. So I think yesterday you guys went into a lot of like deploying a server and deploying an instance of various stuff. And you guys started using like Terraform to do that. And that's an example of automating things. Like you could run, like you could deploy a new instance of a server using a tool. And that tool has a lot of different capabilities. Like it could deploy a server, it could deploy a database, it could do all these things and kind of keep things up and running. And so that would be an example of infrastructure automation. Infrastructure generally meaning all of those different services. And then configuration management. I don't know if you guys did that yesterday, but that's like the configuration files that you guys were like messing around with, like which server am I pointing to, which port am I using? Those are configurations and settings that you would be managing. And instead of doing that in a file by yourself, it's doing that as part of a workflow so that you can automate a lot of it and have everything kind of connecting to each other and knowing which ones should be talking to which ones using which settings. And so there are ways to automate all of that as well. And then deployment, I think you guys know what deployment is, but there's typically a process for deploying things, and part of DevOps is to make sure that everyone is following that process. So that nothing blows up on a Friday and then everything's down over the weekend and everyone's panicking all weekend. And logging and monitoring is more of an internal thing, so that you can keep track of things, make sure things are up and running, make sure things are not breaking, make sure everything's talking to everything. And then incident management is when something happens, when someone deploys something that breaks everything. How do you know it's broken? How do you know what's broken? And then how do you know how to fix it? And then cost management, I know we said that a lot yesterday, but if you don't manage your costs, they scale fast, especially in production, in a tech startup. Yeah, even small startups, like our AWS bill was hundreds of thousands of dollars as a startup. And so that it's easy to be lazy and to let things keep going. But there's a cost to it, and it's really hard to grasp that, like, without having done it and without having faced a bill and having to pay lots of money for something that could have been avoided. But that's a part of the DevOps pipeline to kind of keep that in mind, because you're ultimately given a lot of trust as a DevOps engineer to manage a lot of those decisions, because a lot of the time people outside of your team don't really know or care that much about how you're doing things, as long as everything's up and running. But once things go bad, then like people will start to look into it. Yeah. Cool. Yeah. Again, I've said this like twice already, but I'm not a DevOps engineer. I don't directly work in the field. The only experience I have here is that I've hired a team of DevOps engineers, and we've run a cloud storage startup together, and we needed DevOps because we had a lot of things to keep up and running. Cool. I guess I should have seen the slides a little bit earlier, but yeah, I believe this is pretty much on track with what I said. Okay, so running the business is different than DevOps, mainly in that there's a lot of other non-tech related things that need to happen, like sales, marketing, like incorporation, taxes, that's all part of literal operations, and that has nothing to do with DevOps really. And then infrastructure management, I don't know why that's here, but I think that's a little bit more of DevOps. Deployment. Yeah, security and access control. I think we've covered all of that. Security and access control, I know you guys went over yesterday in terms of like roles and security management and kind of giving permissions to different people for different things. But yeah. Oh, there's literally a whole, okay. I don't know what he means by proto DevOps. I think that's like before you go into production, or like very simplified DevOps. Yeah, I'm not really sure what he means by that. Production focused. Oh, what are SREs? Yeah. Yeah.
So we have all this tech that's supposed to be reliable, like for example, Kubernetes that was mentioned yesterday.
Yeah.
And Docker Compose, Docker, etc. Right, but it somehow still needs 24 hours monitoring. Right? Yeah. So that seems kind of strange, because we created this tech to be reliable in the first place, but we still need to hire a separate person to maintain all of these things.
Yeah.
So it seems kind of redundant. And also, DevOps sounds like it's supposed to be two roles in one person, or maybe a dev should be able to be both dev and operations, as in focused on infrastructure, isn't it?
Sure. So if I have your question correct, it's two questions. One, if everything's supposed to be up and running by design anyway, why do we still need people to then make sure it's up and running? And then two, it's why is it one role of DevOps when it sounds like it should be two or more roles, like developer and operations?
Yes, exactly.
Okay. Let me answer the second one first. So the reason why it's DevOps and not just developer team and then operations team is because typically in a big company, it's a team of teams, right? So like Google doesn't have one DevOps guy, right? Like they have teams of DevOps people, and those teams of DevOps people are in charge of different parts of the DevOps infrastructure. So I think the bigger you go, the more specialized you have to become. But the smaller you are, as we were saying, like it could be one backend guy for a startup, right? Like literally, it could be one developer for everything for a startup, and they would have to be in charge of all of the DevOps pipeline. And so I think the reason why it's typically not broken up into different roles is because operations, as we said, is so much more than just developer operations, right? It's like taxes and paying people their salary. That's operations. And so if you have the person that pays the salary also watching the servers, that makes less sense than having the developer watching the servers. And so I think that's a simple way to think of the difference between like operations and DevOps, and why you would want more like the dev watching that part of the ops instead of having the ops person watching that part of the ops. And then the reason why you still need people maintaining things and keeping things up and running after having designed all these different tools and systems and everything to be up and running all the time is because people make mistakes and things happen and power outages happen and accidents happen and mistakes, typically human mistakes happen all the time. And so that's why you want to pilot flying your plane, even though we have automated plane flying systems, right? Like it's in case one of those systems isn't working exactly as planned, you want that person to be like, nope, don't crash the plane, please, like, and flip that button. And so a lot of it back in the day was a lot more manual. And so even though we've gotten to a point where things have progressed so much where a lot of it's really good and almost everything's perfect, you still want people to make sure that things are up and running and to be able to go and press that button that needs to be pressed when things go offline. Yeah, and so I think it's pretty natural to want at least a person, if everything explodes, to then go and like restart the servers. And so at a bare minimum, I think that's the DevOps engineer's role. And that's why you would want someone to be on call so that, you know, your one guy who knows how to get into the server room isn't like halfway around the world. So, or if he is, to have a backup, right? Cool. Yeah, okay. SRE, we defined continuous integration and continuous deployment. So you'll see CI/CD a lot. CI, the way I think of it is like I is for internal. That's like your internal system and process. Like that's your GitHub repo and how you make, you know, updates to your GitHub repo. That's I. And then CD is like deployment, right? That's like external. It's like what the end users will see. And so if you have a site up and running and then you make a change to your site, that's CI. And then when you deploy your site to production or that update to production, that's CD. And so the whole CI/CD pipeline is from, I would include like the change management process. It's like, hey, we need to change this button from red to blue. From that point all the way to the actual change implemented in your repo, to the change being put on the server, to the server's version going live into production, to then making sure that that didn't make everything explode, to then, if it did explode, to fixing it. Like that's all part of the pipeline. And so you would have to do that for literally every change you make in your entire company. And so to do that, that's why there's such a big focus, and that's why there's so many tools that are available to kind of focus on different parts of that pipeline. Cool. And then agile practices would be one of the ways to manage that process from a like people perspective. So it's typically not a developer that says, hey, I need to change this button from red to blue, it's typically like a user-driven thing or like a product team thing where they're like, hey, our users would love if this button was blue. And then that would then be decided upon by like different people to say like, yes, I agree. I think the button should be blue. Let's implement that as a feature. And then, hey, Bob, can you make this a feature? Can you like implement this? And then Bob will be like, okay, hey, John, like, can you implement this small feature within the dev team? And so all of that would be managed somehow within the people side. And Agile is one of the ways to do that. Cool. And generally that would be like product management or project management as well. I could give a whole talk on Agile because I'm more familiar with that one. Cool. Infrastructure automation. Infrastructure automation. Okay, so there's, yeah.
Oh, sorry, before we go to the next one, I have a question about the CI/CD pipeline.
Yeah.
I mean, who is really responsible for creating it in the first place?
Yeah.
Because I imagine it's both sides. I mean, devs and DevOps people, because they need to collaborate on the internals of it. As in, they need to decide. For example, devs decide on the operating system, I guess, right? And DevOps, they have to, I guess, agree on that and implement that, right? I think, right?
Yeah, it's possible to do that separately. So typically, okay, so it depends on the size of the company and the complexity of the team, really. And so if you're the one full stack engineer for a startup, you choose whatever you want, right? And no one will question you ever. But if you're in like a massive team, you'll typically have like a company-wide process that you're kind of plugging into. And then if you want to change any part of that process, it's like a whole change process that you have to go through. But if you're in like a small to medium startup where you have like, where you're at the point of having a DevOps person and like a developer team lead, you would just talk about it and then you would implement it. So there's like the official answer and then like the practical answer. The practical answer is you guys go to lunch and you talk about it. And then you then make some decisions and you have like a meeting maybe, and then you pull in like other people from the team, like the person who can write the check to approve all these changes that you'll have to start spending money on. And then the people who are then later responsible for keeping things up and running, like QA and, you know, like customer service people or like sales and whatever. And so there's typically a reason why you would be making a change. But if you mean like, how do you make sure it happens in the first place? The initial design of your CI/CD pipeline is typically, honestly, like pretty up to you and kind of random and ad hoc. So you make a decision up front. It's like yesterday, we talked about like how do you know you should use Azure instead of like AWS? How do you know you're supposed to use Terraform instead of like manually putting up a server, right? So that's part of your CI/CD pipeline, and that would be the initial decisions that you're making, where you say, a lot of the time, practically speaking, it's familiarity with the tool set. So whoever is in charge of all of it would then be like, I'm comfortable with Terraform, for example, and then you would probably end up using Terraform. But, or like, I know AWS super well, so you'll typically end up going with AWS, unless there's a reason to not do that. And typically that would be like a money reason or like a Coke versus Pepsi reason where you like have contracts in place and you can only use one or the other. So, oh, in a corporation, there's something called a vendor list usually. And so that'll also restrict what you can use and what you can't use. A vendor list is typically a list of pre-approved companies that you're allowed to use stuff from. So like Coke versus Pepsi as an example, like if you have contracts with Coke, you typically have an exclusive contract with Coke, so you can't use Pepsi products in the Coke stuff. And that's not exactly how it works in software, but it's similar, where you say like, I promise to use like Google stuff. And so you'll use Google instead of the alternatives. Or like iOS versus Android, that kind of stuff. Or Windows versus Mac or whatever. Any other questions before we move on? Yeah, so a lot of the ways that you can automate stuff. So automation is a big word in DevOps, and and I think that's because developers like efficiency. And so if you like efficiency and you know how to set things up in the first place, you also, it's not that much more work to make sure the thing stays up. And if the thing stays up, then I think that's kind of automation. So auto scaling, infrastructure as code, I think you guys covered yesterday. It's just like, you can automate infrastructure, right? I believe. And then auto scaling, you've also covered yesterday, where you can kind of provision different sizes of things, like the servers could be like the bare minimum if that's all you need. Or if people start spiking your traffic, it'll kind of get bigger and it'll go grab more server space as you need it. And then once you're done needing it, it'll kind of get rid of and like tear down server space on its own. So that would be auto scaling. Did you guys cover that yesterday? I heard those terms yesterday, so I don't know if you guys did that in depth. Self-healing is a pretty cool concept. So there are ways to, so there's different levels of it. There's self-healing on a single machine, and I think you guys might have heard of like RAID on a computer if you do like storage stuff. So there are ways to like keep. I think this is kind of getting off topic, but you can set up your systems in such a way that if your hard drive just goes bad or like something it just breaks, there are ways to make sure you don't lose any data from that, and you have like no downtime on your system. So you just kind of take one broken drive out of like 5 drives or whatever. If one of them dies, any one of them can die, and then you can just take that out and then put in a new one and then kind of make it realign. So that's an example of a self-healing like storage system. And so you can do that at scale on bigger systems. And so you could have like an entire data center, theoretically. You could have like a whole data center get hit by a flood and all the computers are dead. And you can have a system where that whole data center is redundantly backed up on a different system. So there's like, it's a much bigger system, and one data center, even though one data center is huge, one data center could be one part of that bigger system. And so you can like take out the whole data center, and then it'll still be fully 100% up and running. And then once that one's down, you just have to kind of go put up another one as fast as you can, and then kind of include that back into the system, and it'll back itself up. Cool. Environments on demand. I think you guys talked about that with like Kubernetes a little bit, if you guys covered that, or like Docker if you've covered that, where you can spin up a whole new like laptops worth of environment. Like you can have an entire operating system in the cloud, and then you can just have 2 in the cloud, or like 20 of them in the cloud if you want. And it's pretty quick. Cost prediction. I think B showed you that cost calculator a couple times, where you can kind of plug in like this is the specs that I need, and this is how many machines I need, and this is all the things I need. And then you like hit a button and it says like, you're gonna probably have to pay like $100,000 for that. And then you're like, okay, I don't need that much. And then put it down. Yeah.
Can you tell a quick estimate or rough estimate on how much more expensive is it to run DevOps, as in like cloud, compared to self-hosted solution? Is it worth it? Where's the line?
Yeah, so I don't think it's necessarily so that's a tricky question. It depends what you're doing. So I know that's like a bad answer, but it really does depend on what you're doing with it and how important what you're doing is. Like, how much is it worth it for you to not be down for 3 minutes a month versus like 5 minutes a month versus like 1 hour a month? Like, does it really matter for you? And so that's one example of where that's an important feature for some people and not an important feature for other people. So if it's a personal project, you don't care if it goes down for an hour. Like, it doesn't make a difference. At that point, you can self-host yourself. And if you have a power outage, or like they're, I don't know, changing something in your building and your server has to power down or whatever, you can then be like, that's fine. And, or you could go buy like an APU, like a power unit, to make sure your things don't go down, if that's really worth it for you. But I think I think the short answer is the less reliable it can be, the more it's okay to do it yourself. If it has to be up and running, you should do it in the cloud. That doesn't guarantee that it won't go down, but if it does go down, you can sue someone and get money for it. And so that's kind of the spectrum that you're playing with. And then in terms of cost, cost is not a static thing. It's like over time, right? So over time, if you need this thing once and you don't plan on ever upgrading it, then yeah, it might make sense. And you're going to use it for like 10 years. Yeah, it makes sense to like have it yourself. But if you just need it and you're not sure if you need it, for example, you're not sure if this is going to work. You're not sure if your startup is going to last longer than a year, right? Like at that point, it's probably better to provision something on the cloud, do all your stuff. And then once you've proven a need that you're like, it's a cost benefit analysis at that point where you kind of say like, we're definitely going to be in business for another 20 years. We definitely are going to use this much space or this much whatever. Then it'll cost this much to do it on Amazon. Let's see if there's a cheaper alternative on one of these other cloud providers. Let's see if it's worth it for us to do it, because on-prem stuff, it's not just guaranteed that your stuff is going to run. You then need a person to like manage your internal systems. And that's not even just a DevOps person. You need like you need like a site engineer, like a literal like network engineer, and people to make sure the power doesn't go out. And that is part of DevOps kind of, but that's kind of blurring on that side. Does that answer your question? Cool. Are there any other questions? Like this whole session is just an intro, so it's really. Let me go to someone else first, and then we'll come back to you. Yeah.
Question: if the company is small, backend engineer take care of. If the company is small, backend engineer should take care of DevOps, and if in the case of the projects deploying to kind of VPS servers and not a kind of Terraform was like that kind of automated tools not supported, and so in this case, what should be done?
In what should be done in what sense?
In case of a company is small and they have to use a simple service, not support Terraform like, and that kind of tools not supported. For example, in our country, Uzbekistan, we don't have any Google or Android, Microsoft data centers, and because our clients asked their data should be in our country, we had to deploy our project on our like small data centers, and of course we didn't use Terraform like or that kind of tools.
Okay, so let me try to repeat your question. So if you have to use your own systems or like smaller systems that aren't as like perfect or whatever, how should I do it best? Is that kind of the question?
Yeah, if Terraform or that kind of tools makes life easier, in case of our so
Yeah.
Do we have to burden ourselves?
Yeah, okay. So if we can't use a specific tool, but we still want some benefits, how can we do it? Is that, or just generally like what's a good workflow? Is that your question? Or
I think DevOps. Let's imagine DevOps, how can I say? For example, we know DevOps because we know Terraform or Azure or like the server management, but our server, VPS server, doesn't support them. So how can we
Okay.
do DevOps in this case?
Okay, so I think just let me try to answer it generally. So in DevOps, there's nothing that says you must use a certain tool. Like even something as widely used as Docker, you don't have to use Docker. There's other ways to do something very similar to Docker if you can't use Docker itself. And so if you're having a problem with using a specific service, there are many alternative services that you can almost certainly find. And a lot of those are not like branded or like running on, official servers in certain countries. Like there's a lot of open source stuff that you can just use yourself. So that's one alternative. You can find an alternative to Terraform or whatever. All of these services, there's an open source free option probably. It's just more work for you to set that up and make that work and keep that going in the first place. But even if not, there's different ways that you can simplify and build a system that works for you. So theoretically speaking, you don't need any tools. What you could theoretically do is if you're going to do like step 1, step 2, step 3 on your command line, you can even just write a script that says like, run this script and then run script 2, then run script 3. That's a way to automate your DevOps. It's just, you're doing that. You maybe run one script and then it runs like 20 scripts for you. And then you can just have like a cron job or something that like runs a new script that just says, check if all my stuff is up and running every like minute or hour or whatever. So that would be like a really simplified version of DevOps to just run on one computer. And you're not relying on other tools necessarily. So I think in DevOps, it's easy to just get overwhelmed by the number of like acronyms and terms and like products and companies and all these things. But like, you have to just remember, like the whole point is for you to be more comfortable and for you to have an easier time. So if implementing all these solutions is making it harder, then maybe just rethink doing that. Like, do you need Kubernetes? Like if it helps you, use it. If it doesn't help you, don't use it, right? So everyone's situation is pretty different. And so if you're finding that you're spending a lot of time trying to implement something because someone told you that it would make your life easier, I would say give it a shot. But then if it's not working, like at some point, just stop trying to use it and go with what works from a practical perspective. And then once things are up and running and you're bored, look at it again and see if you can figure out why it wasn't working for you.
Thank you.
Awesome. All right. Yeah, I think we're going to go into a lot of these in more detail today. And so I'm going to not dive too deep into this side. Unless anyone has specific questions. But maybe we'll just go over. I feel like this is pretty self-explanatory, but maybe not. So security, meaning in the context of configuration management, it's like if you have, for example, a server configured and running in a certain way of a certain size of whatever, then someone should be able to change that if you need to. But you don't want everyone to be able to change that. And so that's why you had roles and different permissions, and you would typically have like a workflow where you say like, if I want to change my server size, there should be a process to do that. And so it could be as simple as like, I tell my boss that I need a new server and he just like approves it or whatever, or a much more complicated system where you have a whole pipeline of decision making. And then you can automate a lot of that if you want, and at the bottom, there's different tools that you can use to automate that flow of being like, I need to change something. And then make sure that that change doesn't break everything else in the pipeline. Yeah, I mean, we've talked about a lot of these things. So I think Kubernetes and stuff you're going to learn tomorrow in depth. There's like a whole session on Kubernetes, and I think there's a whole session on Helm. The ones at the bottom are, the first three are just different file formats that you could use to like package your stuff up. So like MSI, I think you guys would probably know if you use Windows. It's like a Microsoft software installer. It's just a way to like bundle stuff up and then like move the whole bundle without changing anything in the bundle to like someone else's computer, and then they kind of like install it and it works on their computer in a specific way. Debian is a Linux distribution that does that it's a very similar way. It's like a DEB file, .deb. And then RPM would be, I believe it's a Red Hat package manager. So it's like a different Linux distribution, but no one says Red Hat, it's just RPM. I think it's literally like RPM package manager now. But originally it was Red Hat, which is a Linux distribution, like a corporate Linux distribution. Yeah, we talked about all these. Are there any questions on just general terms and general deployment? Yeah. Yeah. Okay. So CI/CD generally. I'll just repeat your question. So it's like, can I talk more about CI and CD in continuous integration?
Yeah.
Do you have a specific question, or just do you want more information?
No, just I want to get a little deeper into it.
Okay. So I think the easy way to kind of see a difference is to do like a super simple CI/CD pipeline and like a super complicated CI/CD pipeline, and just to see the different options, because you could follow anywhere in between. So a simple CI/CD pipeline would be, I have a GitHub repo, or not even, you don't even need a GitHub repo. I have a folder on my computer with all my code, and then I use a way to get all of those files onto my server, or maybe my computer is the server. That's like the simplest CI/CD pipeline. So I run like I don't know, CodeSeoul.com from my laptop, and then my laptop has to stay on all the time or the website goes down, right? So that's I would argue a bad CI/CD pipeline, because it's super unreliable and you're relying on this computer being online all the time and connected to the internet all the time and having power all the time. And so that would be a risky way to do it, but it's super simple, which is great. One step down from that, or like the very opposite of that, would be, I have a team of 50 people keeping CodeSeoul.com or whatever. I don't know if this is our website, but like, so keeping that website up and running. So 50 people have to collaborate on all these features. And then once the features are done, it goes into like a deployment pipeline where a deployment team takes over the code. So there's like the developer team and then like the deployment team, which would typically be like the DevOps team. So the DevOps team would get it, and then the DevOps team has a whole process to say, all right, there's a change that needs to happen. Let's schedule the change for February 1st at 12 a.m. local time. And then at 12 a.m. local time, we have to do these certain things to trigger the website to change. And that could be many steps. Like that could be like 30 steps to get something up and running if you really want it to be that complicated. And the benefit of doing it in a more complicated way is that it's safer, because you have like 30 people checking something is happening properly. And then once it's happened, you then look back and be like, did it happen correctly? And then you you can make this like a super complicated pipeline. But I think your original question was, what was your original question? Like, what is the difference, or like just? Okay. All right. So let me split it into CI and CD. So CI, the simple version of CI would be I make a change on my computer and it's done. That's the simple CI. Like a little bit further would be I use a GitHub repo to change my stuff, and then once it's changed, there's like a log of changes and there's like a version tracking of changes. And then I think that only matters if you have another person to kind of like collaborate with, right? And so I think that would trigger a need for a CI pipeline of some kind. And then if you have a lot of people, you would want a process to change things, like a pull request, right? And so that would be an even more complicated CI pipeline, but it's still relatively simple. And then you can do things like auto merging pull requests. Like you can like automate pull request handling, right? And so that would be a slightly more complicated CI pipeline. And then you can have like a master repo, and then you have like different branches, and then you have like automation on controlling all of the branches, and then you have automation to control the timing at which things get merged, and then you can have like automated testing built into every single commit or every step in that process. And so those are the types of things on the CI side where you can just make that as complicated as you need it to be. And there are benefits obviously for each of those things, but there's costs in terms of like time and complexity for that as well. And then does that make sense on the CI side?
Yes, of course.
Okay. And then there are tools that will help you on all of those steps. And so you can use whatever you want, or you don't have to use any of those things to help you on the CI side. CD side is probably what people are going to focus on today, because that's the more, it's not more complicated, but it's more, there's more products available. And so I think people get caught up in trying to use different products. And on the CD side, again, like you could just deploy to production and that's fine. And that's the most simple way to go live on a site and to make changes to the site. You just make a new site and then put it up. And I think that's the simple side. And then on the very complicated side, you would have, it would just take a really long time to do everything. Like every step, every change is like backed up and checked and backed up and checked and automated and backed up and automated and checked, right? Like, so I think the number of times that happens is, it's important from a consistency perspective from the business side. Like if you're, like for example, if you go to google.com, it's google.com. Like there's a certain expectation you have, like the site looks this way and it works this way. But if that changes suddenly, that's not a good thing unless that was on purpose, right? And so you want things to be up and running, and you want things to be like fast, for example. But I don't know. I don't know if I answered your question at all. But.
Thank you very much.
Okay. So logging and monitoring is basically what it sounds like. So I think you guys worked with this a little bit yesterday, where you were tracking your logs. So when you put something up on your server, it told you it worked successfully or whatever. And then if it errored, it would tell you in the command line as well that it errored. And so once you get into things like automating, so you'll have a server instance up and running automatically. And then if that goes down, there's probably a way to bring it back up automatically. But if that ever happens, you would like to know that it happened, right? So there's the actual fixing of it, but then you would want to know that something wrong happened just for future reference, so that you know that it goes down like twice a day. Like that would be important to know, versus if it goes down like twice a month, that would be different. Like the way you handle that server and the way you kind of approach watching that server is a little bit different. If it goes down every minute, like that's a different situation than it just working flawlessly for a year, right? And so that helps inform you of how much effort you have to be putting into monitoring the CI/CD pipeline. Cool. And then I don't know if you guys have seen like dashboards, like like automated health dashboards. I could probably just Google one. So there's lots of tools that help you visualize that. So logs are not that great, but like if you see like a chart that has spikes of downtime and like spikes of activity, I think that helps inform you to be like, I have to make sure that everyone, like, that I have enough servers provisioned at this time of day.
And Zappix, the example, right?
Huh?
Zappix.
Zappix? I don't know Zappix, but Zappix? Zabbix? Zappix?
Zappix.
Enterprise open source monitoring solution. Yeah, exactly. Stuff like that. DevOps monitoring. Dashboard. Ignore my bad typing. Oh yeah. So there's, let me load this up. This is just a random example. I just Googled DevOps dashboard. So there's stuff like this that helps you visualize. It's like automated testing would be there, and then like deployment status would be there, and then like uptime is like how often your stuff goes down. So uptime, you want it to be 100%, but it's never 100%, but you can get as close to 100% as possible. But yeah, and so stuff like this, it's easy to see this, but if this were all logs, like in a command line, to get this much information in a command line is going to be not feasible. And so that's why like visualizations are important. And there are specific tools that you can use, and you can put it into different places in your CI/CD pipeline to monitor different things so that you can then visualize all of those things. Let's say like, so for example, like even like every time I try to deploy, it doesn't work 100% of the time. And like it fails 3 out of every 10 times. And so you can like break that down as far as you want to be like, how often is it like an internet problem? How often is it my server that's a problem? How often am I using the wrong login credentials? Like you can go down to however deep is useful for you. Oh yeah. And then obviously you can automate everything as well. And then if things go bad, you can automate having the alerts. So alerting is actually interesting. So you mentioned on call. So there's different ways to alert someone. Like you could just in the command line be like, hey, something went wrong. Or you could be like, you can make it so that it emails you some like every time your server goes down, it'll email you. Or you can make it so that it like text messages you or it calls you on the phone or whatever. And so there's different ways to alert. And different levels of alerting that you can do. Like you can like alert like a team, you can alert the on-call person, you can alert the CEO if things go pretty bad. So there's different levels of alerting that you can do. Yeah, so this is a slide you never want to need. So things can go bad really quickly. The meme is like deploying to production is like a meme. And so deploying to production is something that the more complicated your product is and the more complicated your CI/CD pipeline is, the more important the deploy to production is because you don't want things to fail. And so the CI side of it would be making sure that you don't put into the code anything that will cause it to break. And then the CD side is make sure the code, the good code, gets to production safely and stays on production safely. And so, yeah, incident management ownership is, it's like who is responsible for this problem? Like if something exploded, who's in charge and who's gonna get fired if you don't fix it? So that's ownership. And then identifying the problem it can be simple, it can be extremely complicated, especially the more complicated your systems are, because you would then need to track down what's broken, when it broke, why it broke, how to fix it. And that has to happen like fast. So if you guys you've heard of like AWS going down, right? And like half the internet goes down or whatever. And so that is someone's incident management problem. And so someone has to take charge of it. Someone has to figure out what's wrong. Someone has to try to bypass it. Like that's a temporary solution. It's like if this whole server is bad and you're not sure what's bad with it, just the simple solution would be like spin up the same server from a backup that you hopefully have, spin that up, and then route everything over there so that you just bypass the bad system. And then while you're doing that, and once that's up and running, you can then like do a post, you can like dive into what went wrong and try to identify what's happening and why it went bad so that it doesn't happen again. And then that's diagnosing behavior and then repairing it. Ideally, you can repair it, and typically that's either on the code side or like a process side. So it could be on the CI side or the CD side, and then you can just fix it, hopefully. Yeah, and then afterwards, you would do a root cause analysis or a postmortem to figure out what went wrong and how you can prevent it from happening. Cool. Yeah.
Say my website goes down, what are typical steps as a DevOps I should do to fix this?
Okay. I would say that depends on how important this is again. Like, is it a site? Is it a personal project that doesn't really matter? Or is it like a huge company that is having problems? And like, what are the functionalities on your site? Is your whole site down? Like the site doesn't even load? Or is it like a specific button doesn't work? Or does the button work, but like you're getting nothing when you click the button? Or, you know, it's like that's identifying the problem, right? So if your website loads, for example, and the form, like let's say you fill out a form, the form works, it submits, but it just goes to a blank page at that point. Like that's then probably like a backend server, maybe database problem at that point. And so you can isolate it down to that, and then you say, hey, like who's in charge of the backend server? Can you check what's happening? And then if something is happening and it's not your server, if your server's fine, then you have to just dig deeper and try to figure out what's happening. And so typically you would have like I think if you're a small company, it seems like everyone's at a small company. The small companies, everyone would kind of be on alert. It's like, let's all try to figure it out because there's so many different things that could be possibly wrong. Let's all just jump into it and kind of see. But yeah, was that your question? Yeah. All right. Any other questions before we go? Cool. I think we're pretty good on time. I think we just have a couple more slides. Cost management. I know you guys have you guys have definitely seen like the cloud provisioning planning tool. I think that's good, but it's also not super accurate. Like you don't know what you need most of the time. Like you don't know how big your server that you need is. And so I think budgeting is probably one of the better ways to do it. Just to say like, I'm gonna have up to like $100 a month or whatever. And I think that is a more reasonable way to do it if you have the budget for it. And cost dashboards are just kind of like the other dashboard where it just tells you how much you're spending and what you're spending it on. So a lot of the time, like you'll have servers that are up and running and those are pretty constant in terms of cost. But then you have like data storage, which could fluctuate. And then there's data access, which is like accessing the storage that you have. And that's typically a cost that everyone underestimates. So for example, what that means is if I have like a server on the cloud, that's like a computer on the cloud, and then I have like a database on the cloud, I also have to pay for the amount of bandwidth that uses. So if I have like 1 megabyte on a cloud server, for example, and one user has to go download that 1 megabyte, I have to pay for that 1 megabyte to be transferred to the user, which is fine. But then if I have 1 million users, that's 1 million times 1 megabyte that I now have to be paying for the same 1 megabyte. So it's not like a fixed cost. It's like a access cost and like a bandwidth cost that no one really thinks about, which is it's a good problem to have. That means you're getting lots of traffics, but sometimes that's also a bad thing. If you're not making any money from it, if it's just like a for fun thing and you have it hosted, you have to pay for that. Yeah. So setting alerts is good. I think B said yesterday that he has an alert that says if it's over 0, then alert me. And then I think regular reviews is always smart, but we forget. So you could automate that if you want to review your budgets and stuff. Cool. Any questions generally? Literally anything. So we could, I think we could cut the stream and then you guys can ask whatever you want. I'm into the Discord. Yeah. The question